Welcome to Thursday's lesson. Today we're covering a specific solvent. Remember, solvent is the part that does the dissolving. It's the larger part of your solution. We're talking about water and how it's a universal solvent, or at least it's a nearly universal solvent. So why does stuff dissolve in water? Well, there's one major factor in that, because water is what we call a polar molecule. If you remember back to kind of messing with magnets, either in the first semester of FEC or kind of as you got younger sciences, magnets have a positive end and a negative end. That's what it means to be polar. In this case, water has a positive end represented by its two hydrogens, while it has a negative end at its oxygen. Now, I know we haven't talked about bonding or anything like that, so I'm not expecting you to know any of that harder stuff yet. All I need you to know is that water is a nearly universal solvent because it is polar, as a positive and a negative end. A couple of good words that you will need to know. A water chain is held together because of cohesion. That's the attraction between the negative oxygens and the positive hydrogens. It's also known as a big one here. Probably want to make sure you write that down. Hydrogen bond. It's because they're bonded between the hydrogens and another element. Water tension allows it to where like bugs can walk on water in certain cases. And capillary action allows water to be sucked up. I still want you to know those, but those won't be as big as hydrogen bonds and cohesion. The reason why, we'll get back to polarity here. The reason why a lot of polar molecules dissolve in polar water is because when you have both positive and negative ions, it mixes well with water's positive and negative ions. So the main thing is to remember is that and I'll write it out here on the side, at least I will attempt to do so. Like dissolves, and you probably want to write this down as I'm attempting to do this. Like dissolves like. And what that is that means that if water is polar, so polar dissolves polar. So in fact, I will erase that and write that in a different color. So if water is polar, polar dissolves polar. If we're talking about another type, say it's nonpolar, if your solvent is nonpolar, nonpolar dissolves nonpolar. That's why certain things such as oil, sand, and different other things here do not dissolve in water. Big thing to remember right here is this box. Water is called nearly universal solvent because it dissolves so many things. It will dissolve ionic and polar compounds, but not nonpolar like wax or oil. Scrolling down here, we're going to talk now about how we can increase the dissolving, the solution rates, or dissolving rates, excuse me. So the first thing you can do is crush your solute. So say for example, sugar comes in two forms. The one you probably know is in little packets, little blue or yellow packets at the restaurants. That is sugar. That is powdered sugar, or at least crushed up sugar. Sugar also comes in cube forms. If you've ever seen somebody feed a sugar cube to a horse, or maybe you have some of these in your home, that is another way sugar comes into our lives. Well, if you think about it, what happens is that this doesn't have a whole lot of surface area. There's only so much space that this type of sugar can dissolve. So you can crush it to where you crush this type of sugar and it becomes this type of sugar, making particles smaller. It makes more surface area for the solvent to touch the solute. Powder dissolves faster than cubes. Next thing you can do, if you're making hot chocolate, a couple other drinks, tea, you may want to, or putting sugar into unsweet tea because somebody's mean and does that, you can stir it. You stir it, it dissolves faster. If you're making coffee, hot chocolate again, tea from scratch, you want to change the temperature, particularly. In fact, I will write this in the probably a better color. You want to increase it. You want to increase the temperature. Hot liquids hold more solid and also speed up dissolving. It can also hold it to more sugar than cold water, which is why a lot of people with sweet tea, they have to boil their water and their tea first and then add the sugar before it cools off. The last one you may not necessarily be familiar with unless you have done this type of thinking before, and that's changing pressure, particularly increasing pressure. If you ever look at a soda bottle or a soda can, if you ever try to feel it, you notice that the liquid doesn't move a whole lot on the inside. And if you do shake it quite violently, something happens to it. Well, if you increase pressure, forces gases more into solution. So when they put sodas into bottles or cans, they push it down. They push the liquid down with the CO2. The CO2 is forced under pressure and releases the pressure, and the gas escapes. So if you open that bottle, open that can, that is what you can do to add pressure there. Now, these are the main four that you know: crush it, stir it, change temperature, and change pressure. There is a Canvas assignment you will need to do at the end of this, so feel free to use these notes and get after it.